This second video in the Radiant Technologies YouTube Vision course presents a simple outline of the next 13 videos in the order in which they appear. I will provide a brief discussion here of each of the topics. In video 1, once Vision and the Precision Tester were installed, several key components of the Vision program were introduced in progressive fashion. These included tasks, the task library, and Quick Look. Later, Quick Look configuration and execution led to datasets, the Dataset Explorer, the Dataset Archive, and current and executed test definitions. Video 3 revisits all of these Vision elements and introduces new components in a brief summary tour of the entire Vision program. Topics will be introduced that will be presented in more detail as the video course progresses. Datasets, as introduced in depth in video 1, form the primary data management tool in Vision. Experiments, known as test definitions, are conducted and their data archived in datasets. Both experiment design and measured data can be easily shared with other researchers who have installed Vision. Video 4 will show the few steps required to register an existing dataset in the Dataset Explorer. On the other hand, the Dataset Explorer may become very cluttered with datasets. Unused datasets can be easily unregistered from Vision to clean up the Dataset Explorer. The actual dataset file, start.dst, can be left in place or even moved on the hard disk and re-registered with Vision at any time it is needed. This video will also briefly touch on searching for datasets and sorting them in the Dataset Explorer. In the first video, I introduced the hysteresis task, its configuration and execution. The configuration dialog was a complex collection of controls, and most were ignored. I pointed out that the details of the controls could be found in the task-specific task instructions. I focused on the few controls that were needed to do a basic hysteresis measurement. In this video, I will discuss, either briefly or in depth, every control on the configuration dialog. I will present the control's purpose, importance, and any dependence on other controls. I will make specific reference to controls that are common to all or most measurement tasks. In video 6, I will begin to show the power of the Vision program by introducing the topic of Iterative Execution, known as branch looping. The discussion will begin with a side topic that presents a Vision construct known as the user variable list. The selection of an element on the user variable list is key to the configuration of a very special program control task known as a branch task. The branch task is associated with a user-selected task that is above the branch in the test definition. Recall that a test definition is an experiment formed by a linear sequence of tasks configured in the editor and executed in a dataset. On execution, the branch compares the current value of a single user variable with a fixed value. The user variable, the fixed value, and the comparison are all specified by the user. The comparison produces a logical evaluation that will either return the test definition execution to the branch target task or pass it to the next task in the test definition. This video will address the subject of measurement task behavior when it is programmed within a branch loop. In this video, I will perform a brief survey of the available filter tasks. Then I will choose some specific filters to demonstrate their purpose and behavior. I will discuss common options for filter behavior when operating in a branch loop, and will focus on two filters that are designed only to operate in a branch loop. I will demonstrate filters configured to collect data from measurement tasks and filters configured to collect data from other filters. I will show that through daisy chaining, dissimilar data can be plotted together. Finally, I will demonstrate a few configurations that, though legal within Vision, produce data that cannot be understood. This is a demonstration of the importance of careful planning when designing a test definition. Video 8 introduces the PUND task. PUND is analogous to a two-point preset standard bipolar hysteresis measurement. It consists of pulse polarization measurements of fixed voltage magnitude and pulse width. It is particularly useful in determining a sample's remnant polarization at the programmed voltage. In video 9, I introduce a family of tasks that can be configured to collect data over an extended period of time. Configuration and execution of these tasks is similar between one task and another, as these tasks normally involve a number of stress, measure, plot, store sequences. Since the tasks are similar, I will focus on the configuration, execution, and data analysis of the fatigue task. Fatigue stresses the sample with a bipolar polarization switching waveform of user-defined magnitude and frequency. It then characterizes the sample's polarization response using a PUND measurement. As the sample is fatigued by the waveform stress, the PUND response will normally weaken. Fatigue is a single task solution to a complete characterization of this damage mechanism. Video 10 is of interest to researchers who have access to the Radiant High Voltage Interface or HVI accessory and High Voltage Amplifier or HVA. The precision hardware and vision software can be configured to make measurements of up to 10,000 volts. Video 10 will step through hardware configuration using the most up-to-date accessories. It will show how to configure the hysteresis task to make a high voltage measurement, and will demonstrate such a measurement using a sample held in the Radiant High Voltage Displacement Test Fixture, or HVDM. Video 7 presents a discussion, either brief or in-depth, of all available filter tasks. Video 9 offers a summary of the long-duration measurement tasks. Video 11 completes the tasks survey, covering the remaining hardware, measurement, and program control tasks. 4 purchase custom task suites are introduced here, along with a brief discussion of their licensing. Many tasks will be simply introduced with the expectation that the researcher will review the task instructions if they are of interest. Other tasks will be considered in some depth as appropriate. The power of vision lies within the judicious choice from among its many available tasks when constructing test definitions. Data mining is a vision tool that allows any number of tasks of a particular type to be selected from any number of source data sets to be collected together and stored in a single executed test definition, or ETD, in a single user-selected data set. In addition, a single filter task of type appropriate to the type of task being mined can be applied to the data mined tasks. This allows tasks of a common type to be gathered from disparate locations in Vision and compared directly together. The topic of data mining is covered in depth in Video 12. The biggest single weakness in Vision is in the test definition editor. Tasks may be appended to the end or bottom of the editor test definition or removed from the end. The entire editor can be cleared of all tasks. With a little extra work, tasks can be prepended to the top of the test definition. But because of dependencies between tasks, such as the dependency between a filter task and its data source task, or between a branch task and its branch target, tasks cannot be inserted into or removed from the interior of a test definition. For the same reason, tasks cannot be moved up or down in the test definition. Video 13 presents a relatively new tool called the Editor Aid. The Editor Aid presents an interface that allows a fully general-purpose test definition construction. It is done by not establishing dependencies until the test definition is moved into the editor window. The editor test definition can be moved into the Editor Aid and retain all configuration properties except dependencies between tasks. New tasks can be added to the test definition and moved up or down within it. Existing tasks can be moved anywhere or removed from anywhere. The existing configuration can be written to a file for reuse, and the editor window can be cleared, if necessary, and the Editor Aid test definition written back into it at any point. As tasks are written back to the editor, their configuration dialogs are open for review, editing, and dependency establishment. In Video 14, I discuss a vision tool that allows a test definition to be graphically represented to an audience. The tool can be used to display the editor test definition, or a dataset's current test definition, CTD, or any executed test definition. The graphical representation provides a type-keyed color and icon identifier for each task, along with details of task configuration. It also graphically represents dependencies between filter and branch tasks and their associated tasks. Text in the graphical tool can be edited for customization, and the tool can be copied as a Windows metafile for pasting into a Microsoft Office program or other target. Video 15 is a hodgepodge discussion of a number of tools available by right-clicking within a dataset archive. Tools include one of 3 marker icons that can replace an ETD's standard icon, renaming an ETD, renaming a dataset, adding a rich text formatted note to an ETD, and editing, printing, exporting, or deleting the note, directly adding a general information or hyperlink task to the archive, requesting a test definition graph of the ETD. These videos are conceived to be reviewed in sequence. Terminology, for example, used commonly in one video may have originated in an earlier video. Nevertheless, the researcher should feel free to review the videos of most interest and skip those that do not apply. Happy viewing, and as always, good luck in your research.